In this section, we're going to start talking about polar coordinates. So we're going to define what a polar coordinate is. We're going to learn how to convert between rectangular and polar coordinates, and we're going to convert equations between rectangular and polar coordinates. So let's start by learning about the components of polar coordinate and the polar coordinate system in general. So if we have a point, xy, regular point which has an xy values in the Cartesian coordinates. Now the line segment that connects the origin, which is 0, 0, to this point, xy, it measures the distance between the point xy and the origin. Now this length, we're going to call it r. And the angle that measures the angle between the positive x-axis and this distance r is called theta. So now this correspondence between the coordinate of xy and the values r and theta corresponding to that point is the basis for our polar coordinate system. So keep in mind, any point in the rectangular or Cartesian coordinate is connected to an r and a theta value. Now, every point in the Cartesian plane has two values, right? X and y. Similarly, any point in the polar coordinate has two values, r and theta. So instead of having xy to be your point in the plane, you're going to have values of r and theta, where r measures the distance between that point and the origin, and theta measures the angle between the x-axis and the distance r, which is like the line segment. Okay, now since this is a right angle triangle, I can find angles with trig functions. So if you find cosine of theta here, adjacent over hypotenuse, so if this is x, this distance is also x, so it's x over r. Similarly, sine of theta, opposite over hypotenuse, that's y over r. Tan of theta, opposite over adjacent, is y over x. Now let's see here. We rewrote, cross multiplied, and we got x to be r cosine theta. And we got y to be r sine of theta. So these two formulas, we're going to use them to convert from polar to rectangular. So if you have a value of r theta as a point, you can easily just substitute it into your x and y here, and you're going to get the corresponding x and y values. Similarly here, if we go back to the triangle, since it's a right angle triangle, I have the Pythagorean theorem. So we have hypotenuse squared is equal to x squared plus y squared. So now we're going to use these two formulas to convert from a rectangular point into a polar point. You just plug in the values of x and y here, you're going to get your value r, then plug in the values y and x here, and if you take arctan of y over x, you're going to get the value of theta. So let's try an example to see how that works. So if I have a point in the Cartesian plane where x is equal to -3, y is equal to 4, I can easily find the polar coordinate for it, because r squared is x squared plus y squared, so you just plug that in. So you're going to get -3 squared, so that's 9, plus 4 squared, that's 16, so 25. Now, r squared is 25, but I need to find the value of r by itself, so once you take the square root of 25, you get 5. Now here, r could be -1 and -5. We're going to talk about this fact in a bit. So now let's just take the positive value. Now similarly, to find the value of theta, I'm going to use tan of theta, y over x, so 4 over -3. So theta is arctan, or tan inverse, of 4 over -3. Since arctan is an odd function, you can take the negative out. And now you can use a calculator to evaluate that this is almost 2.1. So the point in the polar coordinate is going to be 5 and 2.1. Now in the second part, I have a point in the polar coordinate and I want to find it in a rectangular coordinate. So I'm just going to apply the formulas where x is, first let's, r is 2, theta is 3 over pi, 3 pi over 2. So it's always r theta. Okay, so now let's review the equations. X is r cosine theta, y is r sine of theta. So if you just substitute the values, now cosine 3 pi over 2 is 0, so x is 0. Then we have 2 sine 3 pi over 2, which is negative 1. So 2 times negative 1 is negative 2. So the point is 0, negative 2. So it's really easy. You just use the formulas that you have. Oops. Use the formulas that you have and convert. Now let's review the fact that I talked about before. Every point in the plane has infinite number of representation in the polar coordinates, but only one rectangular representation. Because here, if you see, I could have taken the negative 5 and I would have gotten another value for another point. I could have taken, like, I could keep adding like pi or 2 pi and getting new values, because if you know, like, if my function was, it has a period of 2 pi, if you keep adding 2 pi to your angle, you're still going to get the same values of tan, sine, and cosine, and whatsoever. So that's why we have infinite numbers of representations in the polar coordinate. Now let's look at the polar coordinate system. Here, we call this axis, which we normally call the x-axis, we call it the polar axis. And if you can see, we have these circles and we have these values of the angle. So technically, this is the unit circle where the distance is 1. So here r is 1, r is 2, 3, 4, and so on. So to plot a point in this polar coordinate system, we always start with the angle. If my angle was positive, I take it counterclockwise. We move this into this direction, normally, like we did in pre-calc. If the theta was negative, we're going to move clockwise. Now, once you locate your theta, you want to see whether your r is positive or negative. If r is positive, perfect. We're going to take the distance with the ray of the angle. If r was negative, we're going to take it along the opposite of the ray. So for example, like, if my theta was pi over 4 and r is positive, the point is going to be here, for example, if r was 3. But if r was negative 3, for example, you take, like, if I have pi over 4 and negative 3, you take this ray, but in the opposite direction. So the point would be here, for example. So this method is to plot a polar point in the polar coordinate system. So let's take an example. If I have these 3 points, let's try and plot them. So if I have 2 pi over 4, so this is my r, this is my theta. You always start with theta. You locate the pi over 4 into your circle. So since theta is positive, I'm going to move counterclockwise. So this is the pi over 4. Now let's look. R is 2, positive. So I'm going to move along the ray and I'm going to stop at 2. So that's why we stop here, and that would be our point. Similarly, for the second example, we start with theta. So 2 pi over 3 is here. Now let's look at r. We have r to be negative 3. So since it's negative 3, I take the opposite. We take the opposite and we stop at 3. So 1, 2, and 3, we stop here. So that's why this is our point. And the last example, 5 pi over 4, it's already here. This is my angle, and r is positive, so I'm going to take it along the ray of the angle. 1, 2, 3, 4, and we stop here. So that's my point. So that's it. You always start with your theta. You locate it like you locate any angle on a unit circle, for example, by take it as a general form. Then you see whether your r is positive or negative. If it's positive, you move along the ray and you stop by, like if r is 4, you count 4 circles and stop there. If r was negative, you take the opposite of that ray and also move like -4, for example, you move 4 along the circles. Now we learned how to plot polar points, but how do we plot polar curves? So a polar curve is a function generated by r equals f of theta. So you have a function in terms of theta, and that's equal to your r. Okay, so what we do, like when we plot any function, we have to set up a table. We have to find values of, for example, when we had x and y, we found values of x, we plugged it into the function, we got points, we plotted the points, and then we connected the curve. We connected the points with a smooth curve, and that would be your graph. So similarly here, we're going to create a list of values of theta, find the corresponding values of r, creating the point r theta, plotting the point r theta, and then connecting these points. So if we have the function for sine of theta, now we know that sine has a period of 2 pi. So we're going to have theta to be, all values of theta are between 0 and 2 pi. So what I did here, I chose different values of theta, and then I plugged it into the equation. You can double check my work. I got these points corresponding. So now I'm going to create points where we have r theta. So 0, 0, 2 pi over 6, and so on. Now once you have these points, you're going to plot them on the graph. Once you have the graph, you just connect the dots, and we're actually going to get a curve of the circle here. So you can double check. There's like a full solution in the book if you want to see like more points and so on. Yeah. So now let's see how we're going to convert this equation r equals 4 sine theta into a rectangular coordinates, which means I want to find it in terms of x and y. So to do that, I'm going to take the equation r equals 4 sine theta, and I'm going to multiply it on both sides by r. So we're going to have r squared is equal to 4r sine of theta. Now the reason why I multiplied it by r is because I want to get r squared. Because I know that r squared is equal to x squared plus y squared, which is great because this solves half of the problem. I got rid of my r. And then also using the fact that y is equal to r sine of theta, I'm going to be able to get rid of this side of the equation too. So now if we plug these two into this equation, we're going to get x squared plus y squared is equal to 4y. Now if you take this to the other side, you'll see that I can complete the square here. Once you complete the square, we're going to add 4 to both sides, and we're going to get, y minus 2 squared is equal to 4. We're going to get an equation of a circle in terms of x and y. So this is an equation of a circle with center 0, 2 and radius 2. So it's all about the equations that we talked about at the beginning of the video. These equations can convert any polar equation to a rectangular equation and the opposite. So now let's take other examples. If I have theta is equal to pi over 3, whenever you have theta, you think about tan. Tan of theta is y over x. Now theta is pi over 3. And we know that tan of pi over 3 is just radical 3. So if you plug it back here, you're going to get radical 3 is equal to y over x. Cross multiply, you're going to get y equals radical x3. Equation of a line with rectangular coordinates. So we're done. Let's see if we have r equals 3. R equals 3, you always think about like, oh, I have an r, so I have this equation if I want to convert. Now, if we have r to be 3, so r squared is going to be 9. And we're done. As simple as that. This is an equation of a circle with center 0, 0, and radius 3. Now, the last one is a bit trickier. But like I said before, if I have r by itself, the first thing that you need to think about, like, oh, let me multiply by r to get r squared, and I can connect it to the equation of x squared plus y squared that we already know. But if you multiplied on one side, you need to multiply the other side, which is perfect because it's going to help me too. So I'm going to have r squared is equal to 6r cosine of theta minus 8r sine of theta. Now let's remember, r squared is just x squared plus y squared. Then, if you remember, r cosine is just x, so I have 6x. Similarly, r sine is just y, so I have 8y. So whenever you have something of this form, take everything to the other side, and you're going to notice that I can complete the square twice here. Once you complete the square, you're going to add 9. And we're going to add 16. But anything we do on one side, we need to do to the other side. So I'm going to have x minus 3 squared plus y plus 4 squared is equal to 25. And again, equation of a circle in terms of x and y with center 3, negative 4, and radius 5. So that's it for this section. It's all about the main equations that we've talked about in the beginning, and you can use those to convert anything. And just be familiar with the point r theta and how to plot it and how to work with all of that. Best of luck, and if you have any questions, let me know.